Geotrig, guys, this is lesson 11, day 1. What we're going to talk about today is circles. So, a lot of different things about circles, guys. A circle definition, the locus definition, guys, locus means many. So, it is a locus of all, or many of all the points, or collection of all the points in a single plane, xy plane, that are equidistant from a point called the center of the circle. Okay? So everything is exactly the same distance away from the circle, or center. So, if I wanted to give you guys an example of that, if I call that the center of the circle, and I go that far away that way, that means I'd have to go that far away that way. That way, that way, that way, that way, that way. Like the spokes of a wheel, right? But if I kept on doing that and went to infinity, you would see a circle. If you connected all of the dots around the edge. Guys, what's not part of the circle are all the spokes in that wheel. The center is not part of the circle. The circle is just the stuff that's the same distance all the way around from that center. Okay? That's the definition of a circle. Each one of those purple lines up there is called the... All of these little individual lines are called the radius. It's a line segment that connects a point on the circle to the center. Right? Yep. Then we have something, if you want to go jump down to there, a diameter. So we're going to jump down to the diameter. Diameter, guys, is a chord, which we'll talk about in a second, but it's a chord that passes through the center. Or what? Or the middle? Well, it's definitely 2 radii. I don't know why I have a blank there. I can't think of it right now. Let me take a look. So it says that it goes through the center. It is a chord, but when we call the diameter, we can say that it has a length. And it's the length of the chord is what the diameter actually is. So it's kind of weird how they say length of chord. Because sometimes we'll say, guys, listen. Sometimes we'll stop and we'll say, hey, the diameter is 4. That means that it is a chord that has a length of 4. Okay. A diameter is a chord. It's a type of a chord. So let's go back up and define chord. What do you think a chord is?
A straight line segment whose endpoints both lie on the circle.
Right. It's a line segment whose endpoints are on circle. So basically, it passes inside the circle from one edge to another, and it can be anywhere. Okay, so I'm going to go down to these circles below. There are 5 circles because there are 5 definitions that I wanted you guys to talk about. The first one we already talked about, radius, center to the side. That's a radius. If you have the right radius underneath that, do that. Next one, we'll call a chord. That's a chord. The next one is a diameter. A diameter is a chord because it connects one side of the circle to another side, but it goes through the middle or center. So the center is here, so therefore it goes through the center. That is a diameter. Now, you should also recognize that since it goes through the center, a diameter is actually just the length of 2 radii. Radii is plural for radius.
Radiuses.
Not radiuses.
I think it's radiuses.
Okay? The next one, guys, and the definitions are almost given to you here. The first one is a secant. A secant is a line that intersects a circle at 2 points. Wait. Mr. Konchak, isn't that a chord?
Yeah. No.
What's the difference between a secant and a chord? Because I'm going to say it's pretty much the same thing, but they're not. Right. Guys, a chord is a line segment. And a line segment starts and stops on the circle, versus a secant's a line. And lines never stop or end. So this is a secant. And then to be tangent, it's a line that intersects or touches the circle at only 1 point. Yes and no. Yes, tangent lines actually form right angles. It's going to be later on. So this right here is a tangent line. A tangent line to that circle. But guess what? Later on, I think I'm going to talk about it more, is that if I took a radius and went to that exact point, guess what it forms? 90-degree angles. They form right angles to each other. That means a radius and a tangent line. The radius to the same point on the circle. So that's pretty cool. It's very useful. Trust me. And the very last thing on the bottom there is called perimeter. We don't call the perimeter of a circle perimeter. We call it something funny. Circumference. They have its own name. Well, just something different.
Is that funny?
Might be, might not be. Okay, I already have perimeter. We talked about that one. So the next one we have to talk about is an arc. An arc, guys. I probably should draw another couple circles, so I'll put some on the bottom here. An arc, guys, is any 2 points on an actual circle and all of the points in between them. So when I think of an arc, I think of a curved line, yeah? So that's exactly what we're talking about. So if I had a circle, and I'm going to change colors because I can, from here to there, I would call that an arc. That's arc. Now, here's the cool thing. I can call that A. I can call that B. That would be arc, with an arc on it, AB. Pretty cool. Now, wait. Oh, man. I'm going to skip the semicircle and central angle for a second. For continuing talking about these arcs, it says right here that the angular measure of an arc is the same measure as central angle. Okay, we'll talk about that up here. Okay, but I want to jump to is this major arc. Major arc and minor arc. Here's the issue, guys. If I did not highlight A with a red line above it to B, and I just said, hey guys, come point to arc AB. Half of you guys, maybe more than half of you guys, would go up here and go, there's arc AB. But couldn't someone else also say, this was arc AB?
Or say arc AB is on the little side there.
No, you can't be. You got only two camps. Remember, an arc, guys, connects A to B. They're connected here, but they're also connected down here on the bottom. So therefore, we actually call one of them the major arc. The major arc, when you think of major problems, it's big problems. So that's your the larger arc. So let's change the color, and I'll write that on here. No, we already used that color. So that's your major arc. And then the red one is what we call the minor arc, because it's the smaller arc made up of it.
Oh, so that whole thing is a major arc?
Right, the purple part would be considered the major arc. The minor arc is the smaller version of it.
So basically the one that's highlighted.
Don't think there might not even be highlighting there. It could all be one color. Most of the time your problems are going to be printed in black ink. So all you're going to see is this. Here, I'll change it for you.
Okay, but that would be the up top part.
So if I wanted to ask you where's the minor arc of CD,
On top of
it's still at the top. It's the same exact picture pretty much as the other one. But you got your minor on top, your major on the bottom. It can be flipped. It doesn't matter. It could actually be the same if I'm talking about the arcs on both halves of a... When would the major and the minor be the same?
Oh, square. No.
When would the top half and the bottom half be the same?
Yeah, square.
Not a square. We're talking about circles, guys. Half a circle. Half a circle, guys, goes back up to this one. Semicircle. A semicircle is an arc whose length is half the circumference. Guess what would be attached to that semicircle? Another semicircle on the other half, yes. How about the diameter? Because what does the diameter do? The diameter cuts through the center of the circle, which would cut a circle in half, right? So a diameter would actually create two semicircles. Then, going to the central angle, which has the stars underneath it. Here's a really cool thing. There's something called a central angle. The central angle, guys, is formed when you take two radii and you connect them to the endpoints of an arc and the center. Because the center has its radius, so it has to come from the center. So, what does that mean? It means that here's my center. I just formed an area, a sector. Sector, I think, might be coming up. But here's the cool thing. If I went in here and said that this arc, the minor arc, was, I don't know, let's say 120 degrees. If the central angle, that's the central angle, the central angle is 120 degrees. This note right here says that the angular measure of the arc is the same as its central angle. That means if this angle is 120, the arc is how many degrees?
120.
120. So wait a minute. Let's do some thinking. If the minor arc is 120, what's the major arc? 240. So if this is 240, what's the arc? 240. They're the same. Guess what's going to happen, guys, in your problems? In your problems, you're going to be given various combinations of arc lengths, central angles, and you guys are going to have to find different variables.
It'll be like 39 or something. Right?
If it'll be something that's not so nice.
Yeah.
Next thing there, it says congruent circles. Okay, what does it mean to be congruent? They mean to be equal. And if things are equal, that means they have the same size. What's kind of one of the few things about circles that you kind of need to know to draw it? Think back to the very first definition. No.
So radius.
Radius. You need to know a radius. So congruent circles have the same
Size. Radius.
radii. We'll call it radii.
Yeah, that's how you spell radii.
Okay. Next thing, it's very important to get through our circle problems. We need to talk about inscribed angles. Inscribed angles, guys, are angles that are equal to 1/2 the measure of its intercepted arc. And I don't have an example on here. So, let's put an example on here. This is a circle. Yes? This guys, is an arc that I'm going to say is 70 degrees. That's a minor arc, yes? Can everybody sees that it's a minor arc of 70 degrees? Okay. This is the center of that circle, yes? Give or take. If I connect those, what's x?
70.
It's 70, because the central angle is the same as its intercepting arc. Guys, you're going to have some trouble if you guys are not paying attention to this. Now, that's a central angle. Let me change the colors. This, guys, is called the inscribed angle, the red one. The red one is the inscribed angle. And the inscribed angle originates from the endpoints of the arc to anywhere on the circle. So, what I mean is it can be anywhere. Guess what? That angle that's out here, this one right here, is half of that. You gotta look that way. It's half of 70. And what's half of 70? Oh, jeez. It's 35. Guess what, guys? I'm going to change the color. I'm going to move it. That is also the pink inscribed angle. It's 35. I'm going to change the color again. I'm just using the arc, this arc's endpoints. Watch this one. That green one. It's going to be harder to fit it in there, I think. It's 35. It's 35. Guys, I'm going to pause the video and show you guys on the screen. Homework for lesson 11, which has nothing to do with lesson 11 stuff, because I got to finish it up, is page 88, 3, 4, 11, 16, and 19. Have a fantastic day.